cell contain different types of protein, so we have to isolate those protein to understand the properties and activities of those types of protein. So purification is very essential to understand the properties and activities of specific protein. So the first step of the purification is to isolate the different types of protein in a solution called as a crude extract. In case of if you want to isolate a specific organelle or subcellular fractions, the differential centrifugations is very important. Now, a term that is called fractionation. So, what is fractionation? Fractionation is a process through which the different types of proteins are isolated on the basis of charge, size, and their binding properties in a specific pH of the mobile phase. So the most powerful method of fractionation is column chromatography. Column chromatography is divided into three parts, that is ion exchange chromatography, second one that is affinity chromatography, and third one size exclusion chromatography. So in case of ion exchange chromatography, the resin is used as a stationary phase. So first of all, we have to understand that through ion exchange chromatography, we can easily identify or isolate the proteins on the basis of sign and the magnitude of net negative charge of the protein in specific pH of the mobile phase. So in case of ion exchange chromatography, the synthetic polymer resin is used, and a resin with the negative charge called as cation exchanger, resin with the positive charge are called anion exchanger. So in case of, suppose we take an example of cation exchanger. In case of cation exchanger, the resin with negative charge or negative groups. So the proteins with the net charge can easily interact with the negative group resin. So in case of cation exchanger ion chromatography, the positively charged protein interact with the negative resin groups. So the positive charge proteins are retarded, and the movement of the positive charge protein slows down due to interactions with the negative group of the resin in case of cation exchanger. On the other hand, net negative charge proteins moves faster inside the column and elute earlier. Suppose we take an example of a two peptide, that is peptide A and peptide B. So peptide A with a charge, net charge in a specific pH, that is -4. On the other hand, so peptide A is -4. On the other hand, peptide B with a net negative charge of +2. So peptide A -4 means negative charge protein, and peptide B +2 is a positive charge protein. So which one elute earlier in cation exchange chromatography or in anion exchange chromatography? So in case of cation exchange chromatography, the resins are surrounded by negative group. That is why the peptide A moves faster inside the column because it bears negative charge. On the other hand, peptide B with the positive charge interact with the negative resin. So peptide B is retarded by interactions with the negative group resin. So in case of cation exchange ion chromatography, the peptide A with the negative charge net negative charge in specific pH elute earlier. In anion exchange chromatography, the peptide B elute earlier, because in case of anion exchange chromatography, the resin with the positive groups and the peptide B contain the positive groups, so the peptide B does not interact with the positive group resin. That is why the peptide B is elute earlier. On the other hand, peptide A elute later, or the peptide A is retarded by interacting with the positive group resin in case of anion exchanger. So in the next video, we understand the three types of column chromatography on paper, so we can easily relate the each process more easily.